Hello everyone, myself S.A.Utage, Assistant Professor, Department of Electronics Engineering, Walchand Institute of Technology, Solpaur. Now we are going to discuss digital pulse modulation, adaptive delta modulation. Learning outcome. At the end of this topic, student is able to understand basics of adaptive delta modulation, understand the advantages of adaptive delta modulation over delta modulation. Adaptive delta modulation. To overcome the problem of slope overload distortion and granular noise, the step size delta is made adaptive to input variations. When input is varying slowly, step size reduces. This method is called adaptive delta modulation. ADM, that is adaptive delta modulation, can handle continuous variations in step size. Above shows the diagram for ADM transmitter and receiver. ADM transmitter, the step size increases, decreases depending upon the 1-bit quantizer. If 1-bit quantizer output is equals to 1, then step size doubles for next sample. If 1-bit quantizer output is 0, then step size reduces by 1 step. In receiver, the first part generates step size from each incoming bit. Same process is followed by the transmitter. The previous input and present input decides the step size. It is then acts as input to accumulator, which reconstructs the waveform. Low pass filter smoothens the staircase waveform to reconstruct smooth signal. So this is adaptive delta modulation waveform, in which the problems which were occurred in the delta modulation are overcome. The right side diagram indicates that a granular noise as well as the slope overload distortion. This is what is been removed in adaptive delta modulation. So block diagram consists of most of the part as similar to a delta modulation, as sampler at the input side, then difference amplifier followed by a 1-bit quantizer, impulse train and integrator as a predictor filter. The difference between the delta modulation and adaptive delta modulation block diagram is one more block is added, shown by this blue color, called as step size logic control. Now we are going to discuss how the step size logic control adjusts the size of the level. So this is what we discussed in delta modulation. Now we are going to discuss how this step size control logic works. In granular noise, the output is step size is plus delta minus delta plus delta minus delta. In case of slope overload, it is plus delta plus delta plus delta and so on, or minus delta minus delta minus delta. Now this is the formula for step size logic control, in which delta n is equals to mod of previous delta, that is delta n minus 1, multiplied by current error En plus delta 0 into previous error En minus 1. For n is equals to 0, let us consider at the instant 0, n is equals to 0, the prediction output is assumed to be 0. So analog signal, which is shown by this brown color, is greater than the predicted signal. So error at n equals to 0 is positive, so it will give plus 1. So delta 0 will be equals to delta 0. In case of for n is equals to 1, the case is the delta 0 will follow from 0 to 1 with a step size shown in this diagram. At n is equals to 0, now the staircase output is greater than the analog signal at instant 1. So error signal E1 is negative. So, delta 1 will be equals to delta 0, that is previous delta, mod of previous delta into current error minus 1 plus delta 0 into previous error E0, that is plus 1. That will give rise to minus delta 0 plus delta 0, it will be 0. So there is no increase in the step size between from 1 to 2. So it will be shown by a horizontal black line. Now for n equals to 2 at instant 2, if you look at this diagram, at instant 2 again the staircase output is greater than that of the analog signal at instant 2. So error signal E2 is negative. So delta 2 will be equals to mod of previous delta, that is delta 1, multiplied by current error minus 1, that is E2, plus delta 0 into previous error E1 minus 1. So that will results in minus of delta 0, because delta 1 is equals to 0. So in this way delta 2 will be equals to minus of delta. So there is a decrease in the step from 2 to 3. So shown by this black color. Now at delta 3 n equals to 3, at instant n equals to 3, the staircase output is less than the analog signal in the above diagram. So the error E3, current error E3 will be positive. Delta 3 will be previous mod of previous delta, that is delta 2, multiplied by current error E3 plus 1 plus delta 0 into previous error E2, that is minus 1, results in delta 0 minus of delta 0, it will be 0. So at delta 3 there is no step increase. So from 3 to 4 it will remains as it is shown by this black color. For n is equals to 4, here at the instant n is equals to 4, staircase output is less than the analog signal at instant n is equals to 4. So error E4 is positive. Now delta 4 will be equals to delta 3 mod of delta 3 into current error E4, that is plus 1 plus delta 0 into previous error E3 plus 1, that will result in 0 plus delta 0, that is delta 0. So for 4 instant there is increase in the step size from 4 to 5. Now at n equals to 5, the staircase output is less than that of the analog signal. A E5 error, current error is positive. So delta 5 will be equals to mod of previous delta, that is delta 4 into current error plus 1 E5 plus delta 0 into previous error E4, that is plus 1. That will give rise to 2 times delta 0. So at instant n equals to 5, the step size is doubled. So you will find that increase in the 2 step size, which is shown between 5 to 6. Now at 6, for n equals to 6, E6 is positive because input analog signal is greater than the staircase output. So to calculate delta 6, it will be equals to mod of delta 5 into current error E6 plus 1 plus delta 0 into previous error E5, that is plus 1, giving rise to 2 delta 0 plus delta 0, that will be equals to 3 times delta 0, which is shown at 6. So and at n equals to 6, it is 3 times delta 0. So you will find 1, 2 and 3, which is shown at the here. Between 6 to 7, the step size increases 3 times delta 0. So which is shown with the black color. Now at n equals to 7, again analog input is greater than the staircase output. E7 current error is positive. So delta 7 will be equals to mod of delta 6 into current error E7 plus 1 plus delta 0 into previous error E6 plus 1, which will be equals to 3 delta 0 plus delta 0 equals to 4 times delta 0. So at 7, what you will find, there is 4 times increase in the step, so which is shown by this vertical line crossing the 4 levels. So this is what the output of the staircase output which is following the analog signal even during the small increase in the input variation, that is granular to avoid the granular noise, and during the slope overload distortion. That means in both the cases which we observed a distortion in delta modulation, this has been reduced in adaptive delta modulation by adjusting the step level. So, if you look at the initial part of this waveform, in which there is small increase in the variation in the signal. So, here for some period there is no change in the delta, it is keeping its level same, and some part it is at the negative side it is keeping the same level. This is what it is not changing alternatingly positive negative, positive delta, positive and negative delta. So, and also in this when there is a large variations in the analog signal input signal, the step size is assumed to be increased. So, this is the advantage in which the error is reduced, the granular noise and slope overload distortion. Question: what is the advantage of adaptive delta modulation over delta modulation? The answer is it reduces granular noise and slope overload distortion by adjusting the step size for small signal variation as well as large signal variations. These are the references. Thank you.